Hello, ladies and gentlemen, and welcome to section 8.1 of Mrs. Quinn's geometry class. I'm sorry, 8.1 of Algebra 2. Today we're going to look at composite functions. So first of all, a composite function is a function that maps x onto g of f of x, and whose domain is a set of all values of f for which f of x is the domain of g of x. I know that's pretty wordy, so let's just look at it in application. If this is r of x, and I have d of r of x, I'm simply going to plug r into d. And so everywhere I have x in d, I'm now going to plug in r. So d of r of x is going to equal 0.75 times r of x instead of x. And now I look at what r of x actually is. R of x is actually x minus 500. Now I just need to distribute and simplify. I get 0.75x, and 0.75 times a negative 500 is negative 375. So this is d of r of x. And we use two different notations. We either use this O that shows it's d of r, or we use these parentheses. I like this notation better because it shows that you're now plugging in r instead of plugging in x. Now if I want to evaluate the formula for a specific value of x, I simply replace x with the value, 4,500 in this case, and I get 0.75 times 4,500 minus 375. And hopefully you'll all agree with me that we end up with 3,000. All right, let's go ahead and move on. Now I want to suppose I have h of x and g of x defined above, and I want to evaluate g of h of 3, which basically means I'm going to plug 3 into h. Always start with the inside first. And when I do that, if I find h of negative 3, hopefully you'll all agree that it's negative 8 times negative 3, which is 24. Now that I've found that inside piece, now I'm going to replace this with 24. And everywhere I have x and g of x, I'm going to replace it with 24. And the absolute value of 24 is absolutely 24. All right, let's try in the opposite direction. Notice that the only thing that's changed is which function I'm plugging into first. So first of all, I'm going to plug in and find g of negative 3, and I get the absolute value of negative 3, which is a positive 3. Now I'm going to plug that in right here, and now I have h of 3. And everywhere I have 3 in h, I am going to plug in 3. And I get negative 24. Notice that my answers are not the same. The only time order doesn't matter when you take composites is when your functions are inverses of each other. All right, what if we, again, do the inside first? Let's find g of 5. Hopefully you'll agree with me that g of 5 is simply 1 over 5. And now I'm going to find f of 1/5. And everywhere I have x, I simply replace it with 1/5. When I simplify, I get 2/5 minus 1, which equals a negative 3/5. Now let's go in the opposite direction. First of all, we'll find f of 5, which is 2 times 5 minus 1, which is 10 minus 1, which is 9. And now I'll plug in g of 9, and everywhere I have x, I simply stick it in the denominator. Or sorry, everywhere I have x, I simply substitute 9. And notice my answers are very different of f of g and g of f. All right, now let's look at more functions. And notice that I use this notation with this notation interchangeably. They mean the exact same thing. And so sometimes I even like to have students rewrite the notation because this one tends to make more sense for us. So everywhere I have x in P, I am going to replace it with q of x. So I'm starting with p, which is x squared, and instead of writing x, I'm going to write q of x. And what does p do to it? It squares it. Now let's plug in what q is actually equal to. I have a negative x plus 1, quantity squared, and when I FOIL that out, hopefully you'll agree that I get x squared minus 2x plus 1. All right, how about if we go in the opposite direction? Now, instead of having an x, I'm going to replace it with p of x. And now what is p of x actually equal to? It's equal to x squared. And again, I'm done. Totally different answers. One more example, and then we'll have a practice problem. These are my functions, f of g, f and g. Now let's find g of f. If I find g of f, technically of x, that means I'm putting f inside of g. And so everywhere I have an x in g of x, I am going to replace it with f. So all I've done in this first step is take out the x and replace it with f of x. Now f of x is actually equal to x plus 2. So everywhere I have f of x, let's actually replace it with what it's equal to. And when I simplify, I'm just going to distribute and combine like terms. I get 2x plus 2 minus 1. My final simplification is 2x plus 1 in the denominator. All right. For tomorrow, I'd like you to attempt the following 4 questions, and I will see you on Monday.